Hi, in this video we're going to take a look at solution to question 3 from the 2019 physics ordinary level paper. So this is a question on optics and in particular on the Snell's law experiment, and we're asked the following. Student carried out an experiment to calculate the refractive index N of a material, and our tasks include to draw a label diagram of the apparatus used in the experiment, state the formula used in this experiment to calculate the refractive index, state what measurements did the student take during the experiment and what instrument was used to take these measurements, state why should the experiment be repeated, and also state that what other precautions needed to be taken in order to improve the accuracy of the experiment. So then, I have a diagram over here, so let's just put in the labels. So first one is we need to have a light source because this is an optics experiment, so we need a light source. So we can say that this is either a laser or a light box or even a light source. The light source is emitting a beam of light which hits a surface of a block of glass. So let's call this what it is. As the beam of light enters the glass block, it is refracted. So you can see that it doesn't follow the straight path through the glass block, but it kind of bends a little bit. The path bends a little bit, and then as it exits the glass block, the path bends again. So we're trying to carry out some measurements, and the measurements we're going to take a look at are the following. The angle between the normal at the surface of the glass block, let's call it the incident angle I, and the angle between the line normal to the surface of the glass block as the light ray travels inside the glass block, let's call it the refraction angle R. This line, let's call it the normal. And because we're measuring angles, we need to note that we have a type of angle measurement device, so it could be a protractor. Once we list all those, the light box, the glass block, the incident and refracted angle, and the protractor as well as normal, we should be able to get the full marks for this question. Moving on, we're asked to state the formula used in this experiment to calculate the refractive index. If you recall, we're measuring two angles, angle of incidence I and angles of refraction R. Those two angles are related to the refractive index using the following formula. Refractive index N. Sometimes we use the Greek letter eta, but in this case we can use N anyway, is equal to sine of the angle of the incidence divided by sine of the angle of refraction. This is the formula we need to be using. We are asked what measurements did the students take during the experiments. These were angles of incidence and refraction. And what instrument was used to take these measurements? That was a protractor. Why should the experiment be repeated? Now, anytime we're taking a measurement, we have a level of error in that measurement. That's just an inevitable nature of reality that we live in. So we always have some error included in the measurement. But if we repeat the experiment and repeat the same measurements, we can decrease error of measurement and increase the accuracy. It becomes particularly important if we try to measure refractive indices that are very small, like for instance refractive index of air. So that's quite an important thing. So Other than repeating the experiment, state one precaution that the student took to improve the accuracy. Avoiding error of parallax would be a good one. That means that rather than looking sideways, we have to look straight onto our measurement or our apparatus, so that we don't introduce the parallax error into the measurement and into the experiment. And that concludes this question. It was a nice and handy one, so thanks for watching, and until next time.